Good morning, students. Myself, Vijay Shankar from EC Department, Chevrolet Engineering College. Today, we are going to discuss about the examples of the Z transformation. The last class also we discussed some examples. In the today's class, we already know the a power n mu of n, the Z transformation. A power n mu of n, the Z transformation is z by z minus a. In the positive powers of z, the ROC is right-sided, or it is called it as a one-sided. In the negative powers of z, the a power n mu of n is 1 by 1 minus a z inverse. 1 by 1 minus a z inverse. And the towards the negative values, and this one is towards the positive values. For these also the same Z transformation, 1 by 1 minus a z inverse only. 1 by 1 minus a z inverse. But ROC is z is less than a. ROC is z is less than a. Both in the positive powers of z, z by z minus a and z by z minus a. When the signal with combining of a power n mu of n and minus a power n mu of minus n minus 1. Okay. Instead of a power n, without confusion, we are taking the b power n mu of minus n minus 1 as a signal, combined signal. What is an ROC? ROC for a power n mu of n is greater than a minus a power n mu of minus n minus 1. ROC is less than a. When combining the two equations, a power n mu of n minus b power n mu of minus n minus 1, what is an ROC and what is the Z transformation? Okay. According to the Z transformation definition, the transformation of x of z is equal to Z transform of x of n, and Z transform of the two functions we have. One is a power n mu of n plus the Z transformation of minus b full power n mu of minus n minus 1. And this is a standard signal. Already we know a power n mu of n is a 1 by 1 minus a z inverse. Okay. In the positive powers, z by z minus a with ROC is greater than a. And instead of a power n, we take here the b power n. So it is z by z minus b with ROC is z is less than the b. Okay. Now the Z transformation x of z is equal to z by z minus a plus z by z minus b. The Z transformation. But what is ROC? ROC is one for one function is greater than and one function is less than. So combining the two functions, a is less than z and z is less than the b, means z is greater than a and z is less than the b. So in between of a and b, the ROC. So suppose the radius outside the z is greater than a, inside there is an a is there, radius a, and another circle with the radius of b, here, and for it is z less than means inside the circle. Now there is a overlapping occurs in between of the circles here, not inside the circle and not outside the circle with the radius of b. It is in between of a and b. This is a line here. In between of a and b, there is a overlapping occurs. See, and if a is greater than b, the x of z is a is greater than the b here. The a is a radius and the b is a greater than the a. And now the second method we can see here. The second method saying that a power n mu of n and b power n mu of minus n minus 1. Directly they are substitute there here. Here also the same function we got z is greater than a and z is less than b. And a less than the z and the less than the b. Okay, my dear students, the range of ROC is the same thing. A less than z and a less than the b value. Got it? And another example, x of n is equal to. So you got it, my dear students. The second method means directly you are not taking the a power n mu of n, you are simplifying this function, the 0 to infinity a power n z power minus n minus infinity to minus 1 b power n z power minus n. Okay, we're taking off the values greater than a power n means 0 to infinity mu of n is just 1, mu of minus n minus 1. The value is in between the range of minus infinity to minus 1. Okay, and simplify this to get z is greater than a for one function and z is less than b for the another function. Even though it is in the form of sum of n is equal to n1 to n2 a power n, and it is also sum of n is equal to n1 to n2. Consider it as a by z is a one time, a power 0 by 1 minus ez, and here z by b whole power 1, because n1 is a 1 here. Both the n2 is a infinity. The numerator is a 0, 1 by 1 minus a by z here. And here also the a is there, 1 by 1 minus a z by b. Simplify this one. Again, we will get the same thing, z by z minus a plus z by z minus b with an ROC of a is less than z and less than the b. Got it, my dear students? Another example, x of n is equal to 3 into, and this function is I by 7 whole power n mu of n plus 2 into minus 1 by 2 whole power n mu of n. Both are mu of n only. Both are mu of n. And the function is a power n mu of n, and it is also a power n mu of n. We know the z transformation of a power n mu of n is a z by z minus a. Z by z minus a, and it is a greater than a. Why it is a greater than a, my students? It is a mu of n. So mu of n is always in the greater than only. So take here the x of z is equal to nothing but the z transformation 3 into, because it is a coefficient 3 into. What is the a here? A is I by 7. Z by z minus c minus a is I by 7. You can write is I or 5. Okay, I think it is a 5, my dear students. 5 by 7 plus 2 into, it is also in the form of a power n mu of n. Instead of a, it is a minus 1 by 3. Minus 1 by 3, it is a 5, my dear students. 5 by 7 whole power n as a, and other one is a 1 by 3 whole power n. Okay, don't confuse it. It looks like the I, but it's not the I. 5 by 7. So z by z minus 5 by 7 plus 2 into z by z minus of minus 1 by 3, because it's a is minus 1 by 3. And what is the range? The ROC range is both are is a greater than only. Z is greater than 5 by 7 and z is greater than minus 1 by 7, 1 by 3. And where it is overlapping occurs, suppose the z is like this. Inside there is a z minus 1 by 3 is there, is a greater than, and greater than 5 by 7. So 5 by 7 and the minus 1 by 3, where it is a overlap, you can see that one. Where it is a overlap, that overlapping range only the ROC. Okay. So simplify this. 3z by z minus 5 by 7 plus 2 by z plus 1 by 3, and ROC is a 3 by 5 by 7. You got that. Is a 5 by 7, my dear students. Since it is a both are, it is a greater than value, and whichever it is a high is overlapped. Minus 1 by 3 is less than the 5 by 3, and 5 by 7. Okay. So whenever if we take let us take here the minus 1 by 3 is there, and 5 by 7 is a positive value. So mu of n, if I am taking, so mu of n is greater than minus 1 by 3, and the 5 is also greater than 1 by 3. So where we got the overlapping occurs for both functions is the ROC here. And here there is no any overlapping because the 5 by 7 greater than minus 1 by 3 is a greater than values. So overlapping occurs in only the greater value, the 5 by 7. Consider as a 5 by 7 is ROC. So whichever the value is greater. And another method is also there by using the summation 0 to infinite and 0 to infinite, right, and simplify. And the ROC is Z is greater than 5 by 7. Z is greater than 5 by 7. And similarly, next example, 1 by 2 whole power n, mu of minus n. Don't confuse my dear students. Mu of minus n, this one. Okay. And the minus 2 whole power n, mu of minus n minus 1. Minus n minus 1. Again, this is something mistake we did. Okay. Mu of n, we know the 1 is greater than or equal to 0, n is greater than or equal to 0. Mu of minus 1 means 1 for n is less than or equal to 0. Okay, 1 for n is less than or equal to 0. Here the greater than or equal to 0, and this one is a less than or equal to 0 because it's a folded function. For mu of n, mu of minus n is a folded function. Similarly, for mu of minus n minus 1 is 1 for n is less than minus 1. Got it, my dear students? Now, in the definition of the Z transformation, you can substitute x of z is equal to sum of n is equal to minus infinite to infinite 1 by 2 whole power n mu of minus n, because the given function is mu of minus n, minus, and the summation n is equal to minus infinite to infinite 2 power n mu of minus n minus 1 z power minus n. So keep these two functions as a 1, change the limitations. Mu of minus n limitations is n is less than or equal to 0, because it is a minus infinite to 0. Minus infinite to 0. And this function is minus n minus 1 is equal to 1 for n is less than minus 1. Less than minus 1 is minus infinite to minus 1. The range. So see here the minus infinite to 0, 1 by 2 whole power n z power minus n, minus sum of n is equal to minus infinite to minus 1, 2 power n z power minus n. Take this as a single function, 1 by 2 z power minus 1 whole power n, and minus, it is also change the limitations here, the minus is there. Whenever if it is a summation negative sign, you can change the positive sign, means the power is changed as positive to negative and negative to the positive. So 1 to infinite, I change the minus as plus, 2 power n becomes 2 power minus n, z power minus n becomes z power n. And here also, so the 0 and minus infinite. Now I am changing these positive values. 0, nothing but is a minus 0 plus 0, so both are the same. So 0 to infinite, I change limitations to the positive values. So 1 by 2 whole power n is now 1 by 2 whole power minus n. Z power minus n, now it is a z power n. Got it, my dear students? The two functions, I change the limitations, negative limitations is to the positive value, and change the positive powers and the negative powers to the positive value. Sum of n is equal to 0 to infinite 2z whole power n it's a 1 by 2. Get in the numerator, not the 2z. Okay. Minus is there here. 1 by 2 whole power minus n means 2 power n only. And minus sum of n is equal to 0 to infinite. This is 2 power minus n and the z. Now it becomes of z by 2 whole power n. Z by 2 whole power n. According to our formula, we have n1 to n2 a power n, n1 to n2 a power n, 1 by 1 minus a, because this n is equal to 0. 1 by 1 minus 2z, 1 by 1 minus 2z, and ROC is 2z is greater than, not the greater than, because it's a 0 to infinite only, it's greater than the 1 ROC, and it is also 1 to infinite. 1 to infinite, it becomes of minus z by 2 whole power 1, because it is a value is a 1, and second term becomes a 0 because the power is a infinite. 1 by 1 minus z by 2. Z by 2. Got it, my dear students? And both functions now, it is a z by 2 is greater than 1, and z is greater than 2, and here the z is greater than 1 by 2, nothing but 0.5. So you take the ROC is only the one that up to z is greater than the 2. Simplify this one. So they simplified here. ROC is z is less than 1 by 2. Why it is taking the z is less than 1 by 2 means they got it because both are in the negative powers, not the negative powers. Saying that. So, see here, we change that minus infinite to 0 and minus infinite to minus 1. Mu of minus n and mu of minus n minus 1. I told you here is wrong. This is not a greater than value because it is a less than all. Both the functions is not the mu of n. Mu of minus n and the mu of minus n minus 1. Mu of n minus 1 means towards the left side. Towards the left side means you can take that is a less than the function. Z is less than the 0.5 and Z is less than the 2. Okay, these two are the functions, is not the greater than. These also, and this one is also less than only. Less than, Z is less than 0.5 and Z by 2 less than 1, Z is less than the 2. Got it? Whichever is overlapping means Z is, here the 2 is there and here the 0.5. So overlapping occurs below the 0.5 only. So check that as a ROC. Z is less than 0.5. The ROC is Z is less than 1 by 2. And simplification, see here, 2 power Z 1 by 1 minus 2Z and minus Z by 2 whole power n 1 minus Z by 2. Simplified 1 by 1 minus 2Z plus Z by Z minus 2. What it matters, students? And next example here, x of n is equal to 1 by 3 whole power n mu of n minus mu of n minus 6. So mu of n already we have here the mu of n is the discrete function. Mu of n minus 6 means 6 samples is shifted towards the right side. Now subtract the two functions here. Subtract the two functions at 0, 1 minus 0, it is a 1. At 1, 1 minus 0, these are values, is a 0 here. Up to the 5, all the values will get the mu of n, mu of minus n minus 6 values is a 1. From 6 onwards, see here the mu of n is a 1 and mu of n minus 6 is also 1. So 1 minus 1 is a 0 here. And here also 1 minus 1 is also 0. So only it is a range. Now it is from 0 to 5 only. 0 to 5. So mu of n minus mu of n minus n minus 6 is 1 for the range of 0 to 5. For the range of 0 to 5. See here in the definition of minus infinite to infinite. Minus infinite to minus 1 is a 0. And 6 to infinite is also 0. There is no any negative values here, and there is no any positive values from 6 to infinite also. So both are the zeros. Only we have the ranges from 0 to 5. 1 by 3 whole power n z power minus n. Why it is 1 by 3 a power n is n? This total function is a 1 in the range of 0 to 5. Got it, my dear students? So sum of n is equal to 0 to 5. Take this single function 1 by 3 because it is a z power minus is there 1 by z 1 by 3z whole power n. Expand this function 1 by 3z whole power 0, 1 by 3z whole power 1, and so on up to 1 by 3z whole power 5. And 1 plus, because anything power 0 is a 1, 1 plus 1 by 3z, 1 by is a 9z square, 27z cube, 81z power 4, and 3 power 5 is a 243z power 5. Simplify it. If suppose in this equation, you can substitute z is equal to 0. What happens here? 1 plus infinite, because 1 by 0 is becomes the infinite. The x of z is not exist. X of z is equal to infinite. Got it, my students? So the ROC is greater than, since both of the functions is a mu n and the mu of n minus 1. There is no any confusion in the ROC. But so which values it is exist and which values is not exist. For which values is exist, this value, this function is at z is equal to 0. At z is equal to 0, the function becomes infinite. So take that as greater than the 0 only. Except the z is equal to 0, all the values of z is exist. So I take the range is above the 0, nothing but 0.1. Or let us take it is a equally, you can take that as 0.51, 1.5, so on. All the values except the z is equal to 0. If z is equal to 0, see here. If z is equal to 0, x of z is becomes of infinite. X of z is becomes infinite. Except the z is equal to 0, the entire z plane is a region of convergence. Next example. Now it is in the cosine function 1 by 4 whole power n, 1 by 4 whole power n cos pi by 3 n mu of n. So whenever it is given, the mu of n means ROC is greater than the function only. ROC is greater than the function a. What is a here? 1 by 4. Z is greater than 1 by 4. And it is also multiplied with the cosine function, means it is depends on the cosine function also. So x of n 1 by 4 whole power n cos pi by 3 n is greater than or equal to 0. Why it is means it is multiplied with the mu of n. Got it? Substituting the definition of the transformation, x of z is minus infinite to infinite x of n z power minus n. That is equal to sum of n is equal to 0 to infinite 1 by 4 whole power n cos pi by 3 n z power minus n. So change this cos function as a exponential functions, that is e power jx. What is the x here? Pi by 3n plus e power minus jx minus j pi by 3n by 2. And 1 by 4 whole power n, z power minus n, you can write as 1 by 4 z whole power n. Now split these into two parts. Sum of n is equal to 0 to infinite. 1 by 2 is there here. And e power j pi by 3, it is also n. Take the e power j pi by 3, 4z whole power n. And second function also 1 by 2 is the common. 1 by 4z whole power n and e power minus j pi by 3 whole power n. Now e power minus j pi by 3 by 4z whole power n. Now it is total function as a power. 1 by 2 is a coefficient. Got it, my students? To converge this function, a is less than, because sum of not the sum of sum of n is equal to n1 to n2 a power n is equal to, we know, a power n1 minus a power n2 plus 1 by 1 minus a. What is the a here? A is less than 1. It's a condition. Or n2 is greater than n1. Got it, my students? A is less than. What is the a here? E power j pi by 3 by 4z is less than 1. And e power minus j 4 pi by 3 is 4z is less than 1. One thing is a plus and another one is a minus, means you can take the magnitude. The total magnitude e power j pi by 3 4z is a less than 1. Got it, my students? So now using this function, n1 is 0, n2 is infinite, the second term becomes a 0. And first term becomes a 1, because a power 0 anything is a 1. Only we have the denominator is a 1 by 1 minus a. What is the a here? E power j pi by 3 4z, and multiplied with the 1 by 2 plus, and 1 by 2 1 minus a. What is the a here now? Negative exponential. E power minus j pi by 3 4z. Simplify this one. Simplify. Common of 1 by 2. Take the 4z as a LCM here. 4z get in the numerator. 4z minus e power j pi by 3 plus, and here also the 4z is there. 4z get in the numerator. 4z minus e power minus pi by 3. Minus pi by 3. Now you can find what is the value of e power j pi by 3. E power jx is a cos x plus j sin x. Cos pi by 3 plus j sin pi by 3. Cos pi by 3 is 1 by 2 plus j root 3 by 2. Got it, my students? Pi by 3 is a cos 60 sin 60. Cos 60 is a 1 by 2. Sin 60 is a root 3 by 2. And e power minus j pi by 3 is a 1 by 2 minus j root 3 by 2. Here only the minus term is difference. Substitute this value in this 4z minus 1 by 2 minus j root 3 by 2. And 1 by 4z minus 1 by 2 plus j root 3 by 2. Simplify. The total function will go to as like this. X of z is equal to, after simplifying, taking this as real term, 4z minus 1 by 2. 4z minus 1 by 2 is a real term. In the denominator, we get a minus b plus a minus b into a plus b. Because both the functions here, the minus is there in the plus. Take that is a z minus 1 by 2 root 3 by 2 whole square. Got it, my students? And numerator you can simplify. And z is greater than 1 by 4, we can take it. Z is greater than 1 by 4, and the above convergence when this function also. Why it is a greater than 1 by 4? Here the a power 1 by 4 whole power n is there, the function. And also the other one, e power j pi by 4 is less than the 4z, and 1 is less than the 4z. 1 is less than the 4z, and z is greater than the 1 by 4. The two functions we have, e power j pi by 4. According to the plus and the minus, it is a magnitude we have. E power j pi by 3, 4z is less than 1 because it is a is less than 1. And we already know that is a 1 by 4z. E power j, z is greater than 1 by 4 because e power n mu of n. Z is greater than 1 by 4. Got it? So 1 is less than the 4z, or the 4z z is greater than the 1 by 4. Check in these two functions, the ROC is z is greater than 1 by 4, which is a 0.25 will get. 0.25. So 0.25 this function, and this function is a 0.5 plus j root 3 by 2. It is a less than. E power j pi by 3 is less than the 4z, and the z is greater than the whatever the simplified the function it is. So we take only the z is greater than the 1 by 4 is a ROC for the given function. 1 by 4 whole power n cos pi by 3 n. Got it, my dear students? Now another example, a power n, x of n is given as a power n 0 less than or equal to n less than or equal to capital N minus 1, 0 elsewhere. Or they are saying that is a power n is a mu of n minus mu of n, capital N it is. So according to the definition of Z transformation, x of z is equal to sum of n is equal to minus infinite to infinite, x of n z power minus n, z power minus n. So now you can take here the mu of n minus mu of capital N, because it is a less than or equal to minus n. So 0 to n minus 1 only, the value is 1, and the remaining functions n to infinite and minus infinite to 1. So in the total range, what is the range? We have 0 to infinite is the range. In this, the x of n is given only from 0 to n minus 1. So what is the below value here? Minus 1. And up to the minus 1 to minus infinite to minus 1. This value is a 0. And what is the above value? N minus 1 means the next value is a n. N to infinite. This range is also the 0. Only in this range 0 to n minus 1, the value is a power n. Substitute that. Sum of n is equal to 0 to n minus 1, e power n z power minus n. Both the terms is a 0 here, this term and this term. Sum of n is equal to 0 to n minus 1, a by z, because it is a z power minus a by z whole power n. Now we can use the same formula what we know, n1 to n2. What is the n1? 0. And n2 here, now I am using this function. Sum of n is equal to n1 to n2 a power n is equal to a power n1 plus, not the plus, minus it is, minus a power n2 plus 1, we are saying n2 plus 1 by 1 minus a, and a is less than 1, and n2 is must and should is greater than the n1. Now what is the n1 here? The sum of n is equal to 0, n minus 1, instead of n2 is n minus 1. What is the a here? A by z whole power n is equal to. Now I am taking the a as a by z whole power 0 because it is n1 is a 0 minus a by z whole power n2 n minus 1 plus 1 because n2 is n minus 1 plus 1 whole divided by 1 minus a. A is a by z. According to this condition, what is the a here? A by z is less than 1. So a is less than 1. Not the a is less than 1, a is less than z and z is greater than a. The ROC is z is greater than a, ROC. Now simplify this function. Anything power 0 is a 1 minus a by z whole power. Minus 1 plus 1 is get cancelled here. A power z, a by z whole power capital N by 1 minus a by z. Okay. Simplify this function. Take this numerator having z power capital N. So z power capital N is there minus a power capital N whole divided by z minus a, and it is multiplied with the z will get here the z by z power capital N. Got it, my students? Z by z power capital N. Okay. And z minus a, and suppose if in this function, z is not equal to 0. Z is not equal to 0 because z is equal to 0 means definitely it becomes of the infinite, one condition. And z is not equal to a also because z is 0 means denominator having the z is there, definitely the total function becomes infinite, unbounded. Even if it is z is equal to a also, z is equal to a also, a minus a becomes of 0 and denominator is 0 means infinite. So it is not satisfies these two conditions. Suppose if it is a z is not equal to 0 and z is not equal to a. Except these two values, remaining all the functions, it becomes of bounded. So the ROC is in between of greater than a and 0 less than and less than the a. Actually, it is z is greater than a only you can take, or in between the union. U is nothing but the union, my students. 0 less than the z less than the a, in between of 0 to a, and the union of z is greater than the a is an intersection. The overlapping nothing but. Got it, my students? So, or otherwise, simply we can say except z is not equal to 0, z is not equal to a, remaining all the values of z is x of z function is exist. Got it? Then another example. X of n is equal to 1 by 2 whole power n v of n convolution. This is a convolution, my dear student. Don't think it is a plus. Convolution of 1 by 4 whole power n v of n. Convolution of time domain means what is the frequency domain? Multiplication. The 1 by 2 whole power n v of n is a z minus z by z minus 1 by 2 multiplied with 1 by 4 whole power n v of n is a z transformation is z by z minus 1 by 4. It is a positive power, my dear students. In the negative power, 1 by 1 minus 1 by 2 z inverse. Remember this. That z inverse only 1 by z will get z, and this z will get in the numerator. Okay, positive powers of z is z by z minus a and z by z minus a. What is a here? 1 by 2, and here also a is 1 by 4. Multiply these two. According to the convolution property, time domain is convolution, the frequency Z domain is product. Simplify it. And ROC is, what is ROC? Is in between. Z is greater than 1 by 2 and Z is greater than 1 by 4. Okay. Both are greater than only. This is suppose inside here and here it is a greater than 1 by 4. So 1 by 4 and this range is 1 by 2. Greater than, here it is a greater than only. Greater than 1 by 4 and greater than 1 by 2. Greater than 1 by 2. So which is where it is overlapping occurs here? 1 by 4 it is a greater than, there is no any overlapping here, and greater than the 1 by 2 there is overlapping occurs. So take only the Z is greater than 1 by 2. ROC is Z is greater than 1 by 2. Got it, my students? Now, another example in the convolution only. Another example in the convolution. X1 of n is 2, 1, 0, minus 1, 3 is the sequence is given. X2 is 1, minus 3, 2 is given. So there is no any arrow mark here. No arrow mark means the first value is n is equal to 0. The transformation of a convolution is a product of a Z domain function. So x1 of z having the 4 values from 0 to 0, 1, 2, 3 and 4. 0 to 4 x of n z power minus n. So expand this value as n is equal to 0, the value is a 2. N is equal to 1, the value is 1. So z power minus 1. N is equal to 3, there is a 0 value is a 0. N is equal to 4 minus 1, z power minus 3. And n is equal to 4, 3 z power minus 4. Okay, after that is the x1 of z, we got the equation. And similarly, x2 of z, what is the range of x2 of z? 0, 1, 2. So 0 to 2, 0 to 2, x of n z power minus n. So x2 of z is equal to, expand this value. When n is equal to 0, the value is a 1, z power 0 is a 1, minus 3, n is equal to 1, z power minus 1, n is equal to 2, the value is 2, z power minus 2. So x2 of z we got. According to the convolution, the time domain functions is a product, not a product. Time domain function is a convolution. Free z domain function is product. So we multiply the x1 of z and the x2 of z. So in the next way, multiply these two. 2 plus z inverse minus z power minus 3 plus 3 z power minus 4. Multiply with 1 minus 3 z inverse plus 2 z power minus 2. Multiply. And 2, after getting this, write it order of the sequence, z power minus 1, minus 2, minus 3. There is no 4, 5 and the 6. So write the coefficients as a sequence. x1 of n with the convolution of x2 of n, the sequence is a 2, minus 5, 2, or the 2 is a 1, and z power minus 3, the coefficient is 1, z power minus 4 is a 6, z power minus 5 is a minus 11, z power minus 6 is a 6. Got it, my dear students? Okay, the given function is a sequence. We can write the convolution is also in the sequence. Only have to remember here the convolution in time domain means you can write the product in the z domain. Got it? Find the x of infinite of the below. What is the x of infinite means? X of infinite is nothing but the final value theorem. Nothing but it is a final value. Nothing but is a final value theorem. Final value theorem. So what is the final value theorem? Limit n tends to infinite x of n is equal to x of infinite that is equal to limit z tends to 1 z minus 1 into x of z. Okay. For the first example here, limit z tends to 1 z minus 1 into x of z. What is x of z is given z plus 1 by z minus 0.6 whole square. Substitute the z is a 1, 1 minus 1 is becomes a 0. The first example. For the second example, the limit z tends to 1, z minus 1, z minus 1, z minus 1, x of z. What is x of z? Is given the 2z plus 3 by z plus 1 and z plus 3 and z minus 1. So we have the z minus 1 and z minus 1. Substitute z is equal to 1. 2 plus 3 is a 5. And z, substitute the z is equal to 1. 2 into 4. That is a 5 by 8. 5 by 8, my dear students. So in the final value theorem, you can find out x of infinite for the given function of z domain x of z is equal. Okay. Similarly, the next example, see here, find the x of 0 of the below. What is the x of 0? Nothing but initial value. Initial value. What is the initial value? Says saying that limit n tends to 0, x of n is equal to x of 0. That is equal to limit z tends to infinite x of z into z. Z into x of z. For the first example, if I am taking here, limit z tends to infinite z into, what is the x of z here? Z plus 1 whole divided by z minus 0.6 whole square. 0.6 whole square. That is equal to limit z tends to infinite z. You take the z as a common here. 1 plus 1 by z. And here also you can take the z square as a common because it's a whole square. Z square 1 minus 0.6 by z. So here the z into z, z square is get cancelled. Now you can substitute limit z tends to infinite. 1 plus 1 by infinite by 1 minus 1.6 infinite. This value is infinite. 1 by infinite is nothing but the 0. 1 plus 0 by 1 minus 0 becomes of 1. The value is 1 for the x of z is equal to z plus 1 by z minus 0.6 whole square. See, the value is 1. In similar fashion, you can substitute z tends to infinite z into 2z plus 3, z plus 1, z plus 3, z minus 1. Take the z as a common in the numerator, 2 plus 3 by z. And here also take the z is a common in all the three terms. That becomes of z cube, 1 plus 1 by z, 1 plus 3 by z, and 1 minus 1 by z. Okay. And z get cancelled, and here the z square is there, z cube is there. So z. Now we can substitute the z tends to infinite, and numerator having the z is there. Not the numerator, denominator having the z is there. Because the numerator z square and denominator is a z cube. Z square get cancelled. You get the 1 by z into this total function. 1 by z, 1 by infinite becomes a 0. total function becomes a 0. The first example, initial value is a 1. For the second example, the initial value is a 0. Got it, my dear students? Now you go for the another examples. Okay, it's complete of the Z transformation. Examples of Z transformation. Next is the inverse Z transformation. I will give the brief explanation how we can find the inverse Z transformation examples, and tomorrow class you can do the with equations. So what is the Z inverse Z transformation? X of n having the Z transformation is x of z, and x of z inverse Z transformation is x of n. What is the formulas for here? This is the definition of a Z transformation. Z transform. X of z is the sum of n is equal to minus infinite to infinite x of n z power minus n. And inverse Z transformation formula. We use this formula to derive Parseval's theorem, and another one is there. So one of the two properties we derive by using 1 by 2 pi j, the multiplication also. Multiplication property and Parseval's theorem, we derive this by using this inverse Z transformation formula. Inverse Z transformation formula, and this one is a Z transformation formula or the definition. 1 by 2 pi j, the integral x of z, z power n minus 1 dz, inverse Z transform formula. So let the x of z is b naught z power n, b1 z power n minus 1. So decreasing this power, and b1, b2, b3, and so on the bm, capital M minus students. And similarly, the denominator is the z power n, capital N, plus a1 z power n minus 1, a2 z power n minus 2, and so on. The maximum it is a suffix n, capital N, where b0, b1, b2 are the numerator coefficients. A1, A2, A3, and An is a denominator coefficients, and here is a Z power n. There is no any A0. Remember that, my students. The roots of the numerator are called as zeros. The roots of denominator are called as poles. Zeros is represented in the plane is like this 0, and poles we can represent it as a cross mark. Got it? Basically, there are four methods to find or inverse the transformation by using the power series or long division method. Power series or long division method to do the inverse transformation, or to solve or to evaluate. Basically, there are four methods to evaluate or you can solve the inverse transformation by using the power series or the long division method, a partial fraction expansion method, and a residue method, and finally by using the convolution integral method also. By using the convolution method simply. Okay, because it is a Z transformation, you can use the convolution in the discrete also. Not it is an integral method. Integral we are using for the continuous. Okay, there is a four methods we are using to find out the inverse Z transformation for the given function x of z. The four methods are power series method or long division method, partial fraction expansion method, second method, and third method is a residue method, and fourth one is a convolution integral method. Okay, these four methods we'll discuss in the tomorrow's class. Any doubts, my dear students, in this total Z transformation examples? Okay, thank you.